I have not uploaded for several weeks because of this. Welcome to another episode of how I built my own track spikes a long time in the making. I've been trying to come up with viable cushioning for these racing spikes for a while, and I've had to do some pretty interesting things to actually come up with something. In the previous episodes, I've used just foam from cheap flip-flops, but that stuff isn't quite what I want. It's a little too soft. It's not quite bouncy enough, but the most important thing is I can't cut it out to the correct shape because they're just not big enough. So I've looked around for a long time, and it seems impossible to find actual shoe grade EVA foam that I could use in these shoes. Like, there doesn't seem to be any just stock sheets that I could buy or anything. I have been able to get my hands on some foam mats, but like the sandals, they're just not bouncy enough. They might be a little too soft, and they'll just probably feel dead if that's all I have under my feet. I realized pretty early on that I'd have to use something other than foam that I could just find, and this is when I was inspired by Nike's latest performance running shoes. You know, you have the Nike Alpha Fly or some of their newest spikes that are using Nike Air technology in them. The thing about the spikes, it's really interesting because most spikes, even from Nike, almost never use this technology. They never use the air cushioning. What I understand about Nike Air is that it's a polyurethane bag that's pressurized to 15 or 20 or 25 psi. I do know that the Alpha Fly's airbags are pressurized to 25 psi, and I think 15 would be kind of low because that's almost exactly atmospheric pressure. Inside of most Nike Air units are these tensile fibers that keep one end of the bag close to the other. This helps it keep a flat shape instead of just ballooning into a more spherical shape. This is how it can just be put into a bunch of shoes. Like, you can't run on spheres, but running on something flat, of course, makes a lot more sense. How Nike Air works is it's kind of simple. The air compresses and bounces back to provide energy return. I think this technology is pretty underrated. It supposedly has a 90% energy return, which is pretty much the best it gets on the performance running market. Even Nike's Zoom X foam, which a very big deal has been made of recently, is about 80%. And that's really high still. And I think this 90% energy return is why we're seeing it in Nike's latest running shoes. So because the foam I have isn't all that great, I figured I'd probably have to 3D print something. Some kind of cushioning that'll help me out. So could I make it similar to Nike Air? So the major goals and challenges I'd have to overcome is that I have to create a bag that's completely airtight. And the other thing is I need to create tension from one end of the bag to the other so that it stays flat into a shape that I could actually use in a shoe. And I need to be able to pressurize the thing and seal it. Again, completely airtight. So the first thing I started with was I was just welding these nylon sheets together with a soldering iron, and I just couldn't get those even airtight. I just kept going around and around, and there's just a hole somewhere I could never patch up. So then I got some TPU filament, or thermoplastic polyurethane. Is a much softer material. It's a lot more flexible, and it makes a lot more sense to make a bag out of this stuff than it would be to make a bag out of nylon. Nylon's still pretty rigid. So the first thing I did when I got this filament, I printed bag-like structures even with tension printed inside of them, but they just weren't airtight, and the way I had printed them, there was no way to get air in or out. I found pretty early on that I could only get 3D printed TPU sheets to be airtight. 3D printing walls just didn't work for that. So I was able to weld the edges of these sheets together with a heat gun, and then I did have something that was completely airtight. But then I still needed to be able to inflate these things. Just making an airtight bag doesn't really get me where I need to be. So the first thing I did is I thought I would need some kind of one-way valve that I'd be able to print out of this material, and I'd be able to use the bike pump with the needle to inflate it, and then I could just take it out and it wouldn't deflate because I'd have a one-way valve. And I could even still weld that opening shut just to make sure it's totally 100% airtight. But with the duckbill valves, I just couldn't get that far. I printed many different designs of different sizes. And what I did for these is I'd print the duckbill valve and I'd just use the X-Acto knife to cut a little opening. And what these valves are is the pressure inside of something is supposed to keep it closed, while pressure from inside the valve itself should open it and cause air to flow through it. So next I tried to replicate the air valves you find at like basketballs or soccer balls or volleyballs. Those are the ones that you use the needle pump, and you can just pump it up and you take the needle out and it's completely airtight. Although I wasn't able to replicate this with the filament that I had because the rubber used in these valves is a lot softer than what I had to work with my TPU filament. And like how these work is you just put the needle all the way through, but it still manages to stay completely closed when the needle is out just because of how it's made, and that's kind of the nature of how soft it is. If I tried to do that with TPU, I either wouldn't be able to get the needle in, or I'd probably rip the material if I got it all the way in. So the next thing I decided is I would just make a valve like a cylinder where I insert the needle, pump it up, but I leave some space between the actual bag and the place where I have the needle so I could just pinch that off. And this was actually where things started working. So I would pinch off the opening with the pump still connected, then I could disconnect the pump and it would still be airtight. With the opening ready to work with and no needle inside of it, I could weld that shut. And here's my first bag that I've gotten to be completely airtight and pressurized. But now, how do I keep the tension? No, how do I get this bag to keep its flat shape? It's just round. So this is where I got some more headaches. I went through a lot of ugly designs trying to like come up with how I do the tension, like maybe some nylon webbing from one side to the other that I'd somehow glue onto these TPU sheets, or I would just print some kind of design in TPU and then I would just glue that to the sheets. But none of these were all that viable. The solution actually ended up being pretty simple. I was getting a little desperate, so I was just scrolling through the infill options in my 3D printing slicer, and I just went through one infill and I thought maybe I could cut out some of the infill after printing and then weld all the edges together. But none of them seemed to work until I clicked on the concentric infill. And that was exactly what I needed. This stuff was super easy to work with. So after printing these designs, all I had to do was just cut out the outermost wall and then the outermost infill wall. And then I could weld the edges of the sheets together, and this design would print with a working valve on it. So I could just use that as the inflation valve. That's when I was able to produce a flat pressurized bag. So after all these failures, I got really close to replicating Nike Air, but I still have progress to make. I have tried this current formula on maybe 7 or so bags, and I've only gotten 2 or 3 of them to be totally airtight. And even then they seem to lose pressure. At least it's not as bad as the other ones that have failed completely, where I think I have it welded shut, but it loses pressure in just a minute or so. Or maybe it would take a day to lose pressure. But I still have the ones that have maintained a decent amount of pressure, although I want them to maintain a little more. And because of this, I am thinking of other valve designs that work great with this pinching and then removing the needle kind of method that I've come up with. But so far I'm not getting that much progress, but we'll see where I get on that. I hope to put 3 of these bags each in one shoe, so 6 bags total. So that would be 2 in the forefoot and 1 in the heel. Those are the major points of contact with the foot and the ground, where the foot exerts pressure on a shoe or just the ground. So as you can see, I have cut out soles from the foam mats, and of course they're not great cushioning, but I hope I could compensate for that with the airbags inside. And maybe I could even compensate for the lack of shape and size in the sandal foam using these bags. So that's the progress I've made on the airbags, which have slowed me down quite a lot on this project. Although I'm still pretty excited about it, I feel pretty accomplished getting where I have with these designs. And even after I get these working, there'll be a few things I still have to do with the overall shoes. Yeah, I'll have to find a way to really glue the upper to the sole. Then I'll need just a little insole in there, and then I'll have to glue on the plate. I feel really accomplished overcoming these challenges that I have so far with this project, so I really appreciate that you've been watching this. I'm excited to keep going, and I'm also excited to perhaps use these airbag designs in other projects coming up too. If you want to see what else I've got in store for the future, you can subscribe so you don't miss anything. And with that, stop wearing elf shoes.